Hello my dear students. Now we are heading towards the third week lessons. In this week we will learn about amplitude modulation, frequency spectrum of the AM wave, AM power calculation, AM transmitter, TSPSC, that means double sideband, single sideband SSPSC, and VSV vestigial sideband, and FM modulation and FM transmitter. So first of all we have to know what is modulation. So here you can see there is a carrier signal, there is a modulating signal, and that is the amplitude modulated carrier. In modulation process of changing the parameters of the carrier signal in accordance with the instantaneous values of the modulating signal. That means when we send a message signal, when we want to send the message signal, that is the message signal, that's the message signal, and that is the carrier signal. We have to mix it out in modulation process and get the output like that. So we have to use the carrier, a high frequency signal, and the message signal is not more than the carrier signal. The carrier signal is high frequency signal, and that has been mixed with the message signal. And for modulation technique, the instantaneous value means that you can see here it's quite similar to the message signal, the amplitude part in both sides. There is the AM amplitude modulated carrier. So it's one kind of an envelope that carries the signal out of it, and that is known as the envelope of the signal. So that is the high frequency signal inside, and the modulation is like that, the multiplication of the two signals. So in that that's not being the added thing, that is really the thing of multiplication. The multiplication of these two signals will create this kind of signal. In that signal, the outer boundary and the lower boundary is just carved like the message signal. So this message signal is quite secured under the carrier signal, and carrier signal is on the center, or on the just like thing that under the protection of the message signal, and the message signal is quite easy to carry out from transmitter to receiver. Now the advantages of modulation. So the reduction of antenna size, no signal mixing occurred, increased communication range, multiplexing of signals, possibility of bandwidth adjustments, improved reception quality. So these are the advantages of modulation. So the thing is that it is quite helpful in antenna size reduction. So when the frequency is higher, the antenna size is quite lower, but the coverage will but it will not cover most of the area. So modulation gives the optimum size of the antenna to carry out the signal. So no signal mixing, increased communication range, multiplexing of the signal, possibility of bandwidth adjustments. You can adjust the bandwidth out of it, and improved reception quality. The reception quality also improved in that situation. Now that is the types of modulations. There are probably two types of modulations: continuous wave modulation and pulse modulation. In that part of continuous wave modulation, we have got two other types: amplitude modulation and angle modulation. And angle modulation has been divided into two modulations: frequency modulation and phase modulation. Pulse modulation has been divided into two parts: analog modulation and digital modulation. And analog modulation, again in pulse setting modulation, in analog modulation again divides into three parts: PAM, pulse amplitude modulation; PWM, pulse width modulation; PPM, pulse position modulation. And digital modulation is just one type. The pulse code modulation is known as digital communication in digital modulation, pulse code modulation, or PCM. And another part of the PCM is delta modulation. Now you can see the amplitude modulation. There is a message signal, and there is a carrier signal with high frequency. When the amplitude of the carrier signal is changed according with the amplitude of the message signal, then it is called amplitude modulation. Now you can see the same thing that I have described before on the definition of modulation, that the certain area or boundary is just the curve of the message signal. It follows the curve of the message signal, and the internal signal, the pattern is same as the message signal, but the internal signal has been totally governed by the carrier signal. So when it governed by the carrier signal, so this kind of high frequency signal is not easy to intercepted by the noises, and that could easily transmit from transmitter to receiver part. Now there is another part, that is the amplitude modulation. How the amplitude modulation will come into the act by mathematical expression. As you can see here, in mathematical expression, if we have to find out the modulating signal or message signal or baseband signal, so these three these three terms are quite similar. The modulating signal, the message signal, and the baseband signal are the same. That has been denoted as MT AM cos twice by FMT. As it is a sinusoidal signal, so that has been derived as cos twice by FMT, where FM is the frequency of the modulating signal, where AM is the amplitude of the modulating signal, and the MT is the total signal of modulation. And carrier signal CT, that is the AC cos twice by FCT. FC is the carrier frequency, and AC is the carrier amplitude. So in the modulating the equation of amplitude modulation, modulated wave, the amplitude modulated wave is the multiplication of these two waves, this and that, CT into MT. But what did we get here? The thing is that the modulated wave, the theory of modulated wave is like that, that will be like ST. The modulated wave is the carrier frequency is mixed with that, that is CT, plus you can get C of CT into MT. Then you can get the result out of it. Then you should just put the value there, and there is some shifting here. The thing is that just the AC shift cos by FT, and AM cos twice by FMT. So here one thing across in your mind, why the modulation took place like that, whether we are just multiplying the two parameters, why does the thing happens? The thing is that when did you multiply, the AC doesn't multiply in that sense. The multiplication just occurs between these two phase components, like cos twice by FCT and cos twice by FMT. Thus the thing occurs. Whenever you add this, that will be CT, plus that is MT, the signal will be that MT into cos twice by FCT. There is no AM here, that you should multiply, that I have given you previous equation. That's not MT into CT. Okay, so my apologies on that. But the thing is that the main basic things region is like that. So after that we can calculate this.